Welcome to our lesson on one of the most famous and useful tools in geometry, the Pythagorean theorem. By the end of this session, you will be able to identify the parts of a right-angled triangle, calculate missing sides, and use it to verify if a triangle is right-angled. First, we must define the theorem. It only applies to right-angled triangles containing a 90-degree angle. The longest side, which is always directly opposite the right angle, is called the hypotenuse. We usually label this side C, while the two shorter sides are labeled A and B. The theorem states that in any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. It is absolutely vital that you always start your working by writing out this initial line. It sets the foundation for your calculation and prevents simple errors later on. Our first objective is to find the length of the longest side, the hypotenuse. Let's look at a triangle where the two shorter sides, A and B, are 3 centimeters and 4 centimeters. Remember the golden rule, always write the formula first. Now we substitute our known values into the equation. 3 squared is 9, and 4 squared is 16. Adding those together gives us 25. To find C, we must perform the inverse of squaring, which is taking the square root. C equals 5 centimeters. The hypotenuse is 5 centimeters long. Notice how writing the first line clearly guided us through each step. What happens if we already know the hypotenuse but need to find one of the shorter sides? The process is very similar, but it requires a bit of algebraic rearrangement. Let's look at this triangle. We know the hypotenuse is 13 centimeters, and one side is 5 centimeters. We need to find the missing side, which we will call B. As always, we start with our foundation. A squared plus B squared equals C squared. Substitute the values we have. It doesn't matter if you put 5 as A or B, as long as 13 is C. Calculating the squares gives us 25 plus B squared equals 169. Now we need to isolate B squared. To do this, we subtract 25 from both sides of the equation. So, B squared equals 144. Finally, take the square root of 144. B equals 12 centimeters. The missing side is 12 centimeters. By writing the initial formula, we could clearly see that we needed to subtract rather than add. In the previous examples, we used whole numbers that worked out perfectly. These special sets of 3 integers that satisfy the Pythagorean theorem are known as Pythagorean triples. The two we just saw are the most common: 3, 4, 5, and 5, 12, 13. These triples are incredibly important because they appear frequently in exams and construction. If you recognize them, you can often find a missing side instantly without needing a calculator. Let's look at a few more. 8, 15, 17, and 7, 24, 25. Furthermore, any multiple of a triple is also a triple. For example, if you double the 3, 4, 5 triangle, you get a 6, 8, 10 triangle. If you see a right-angled triangle with sides of 6 and 8, you know immediately the hypotenuse must be 10. Recognizing these patterns saves time and builds your mathematical intuition. We can also use this theorem in reverse. This is called the converse of the Pythagorean theorem. It allows us to prove whether a triangle is right-angled just by knowing its side lengths. Our goal here is to verify a right-angled triangle. If A squared plus B squared equals C squared, the triangle must be right-angled. If they are not equal, then it isn't. Let's test this triangle. The longest side is 12, so that must be our C. The others are A and B. Again, start with the formula to test the relationship. Substitute the values, 7 squared plus 9 squared, and 12 squared. Calculate the squares. 49 plus 81 versus 144. 130 is not equal to 144. Since 130 does not equal 140, the Pythagorean relationship does not hold. Therefore, we can conclude that this is not a right-angled triangle. This is a powerful way to verify geometric properties using only arithmetic. To wrap up, let's review what we have covered today. You are now equipped to handle right-angled triangles with confidence. First, identify the hypotenuse, which is the longest side opposite the right angle. Second, calculate missing side lengths using addition for the hypotenuse and subtraction for shorter sides. Finally, verify right-angled triangles using the converse of the theorem. We've seen that the most important step in any of these problems is to write down the initial formula. A squared plus B squared equals C squared. Whether you are finding the hypotenuse, solving for a shorter side, or checking for a right angle, this starting line keeps your work organized and accurate. We also explored Pythagorean triples, like 3, 4, 5, which can help you solve problems at a glance. Take some time to practice these calculations. Remember to identify your C side first and always show you're working. You have now mastered the basics of the Pythagorean theorem.